Hey everybody, Sean Harrington here. Okay, so this is the actual build video for the Aquarius MX. I do have my vent fan on, so it's a little loud. I will probably do a little bit of an overdub on this in sections. I have the components that are necessary here. Here's the PCB. Let you focus on that. Now notice this is the Aquarius macro expander. That was the earlier version, the earlier name of this. The new version of it does say Aquarius MX. Some of the silk screening over here has been changed a little bit, but it's basically the same board. So everything I do here is what you would do if you were making your own. Along with that, I've got the components here. This is the I/O header for the joystick. These are the actual joystick ports. This is the 5-volt balancer. This is the reset circuit. Looks like a transistor, but it's really not. It's a reset circuit. I have a couple of pin headers here for the high-low selection on the ROM. I have all of my chips here, the sound chip, the 2 AY chips, the ROM. Those all have sockets. But then I also have the RAM, the 2 address buffers, and the clock divider, which are soldered directly on board. Let's see, what else do I have? I also have the CH376S USB interface. So I'll try and zoom this in as much as possible so people can see what the pin headers on those look like. I apologize if it's a little fuzzy, but this is the device you want. I linked to the correct one in the bill of materials. We'll set this aside here. Got our 3 resistors that we need. We have 8 balance capacitors that go above each of the chips. We have another socket here for the CH376. And then we have a BC548 NPN transistor, which completes with the resistors, it completes the audio circuit. So this is the PCB. We're not going to cover programming these ROMs. That's going to be a separate video. We're not going to talk about putting it into the case or any of that, although I do have the components here to mount this on here, which I'll show you how to do. This will be the finished PCB. Okay, so let's talk about some basics about how I build a PCB. I generally start with the lowest components, the components that are shortest. It's kind of like if you're planting a garden. You want to plant the plants that are closest to the ground, because once you start planting bushes and shrubs around them, it gets harder to get in there to do that. So we're going to put in the resistors first right here. Then we're going to come in and put in these capacitors. Then we'll put in this capacitor here, which is a polarized electrolytic capacitor. Then we'll put in the hard-mounted chips, the solder chips. Then we'll put in the sockets. Then we'll start to put in the headers. Last, we'll put in these, the joystick ports, and then we'll mount the CH376 into its place. The way I keep the components in place are I use this sort of flexible eraser. Sometimes it's called flexible eraser. You can also get it as Quake Hold. It's a rubber putty, and it's what I use to hold components in place. So let's get started. Down here in this section of the PCB is the audio circuit, and that's where we have the 3 resistors. The first one that you need is a 10K resistor. The color coding on that looks to be, let me get my spectacles here so I can make sure I give you the right color coding. Color coding on these looks to be brown, red, black, black, which is 10K. At least I believe that's the item, but I've already got them marked on my components. So the 10K goes right here. You slip the 2 legs through, bend them as close as possible to the actual body of the resistor, and we're going to solder all 3 of these at once. So you kind of clip that down in place and it should pop. I'll tend to use a little pair of pliers from the back to pull down on it so the leg snugs up in place. And then from the front, I will put a small piece of the putty to hold it in. Next up is the one at the top. That is a 470 ohm, not 470K, but 470 ohm resistor. We're going to take one of those off. I'll pre-bend the legs on this. I don't have the color code right now. It looks to be yellow, purple, black, I believe, is the thing, but I've already got them marked. So if you have a bag of chips from your supplier, from whomever you get the components, it should already be marked. So we're going to take another piece of the putty and put it on there to hold it in place. Last but not least, I've already got one taken out, is the 4.7K resistor. It's going to go on the right side of that spot where the transistor goes. I'm going to pull it in place here. Get it nice and locked down, looks good. And then we'll take a final piece of putty and put it right there. We're going to move our chips out of the way for a second so I don't get them damaged. We're going to flip the board over, and we now know which resistors are where they need to be, so I'm going to move these out of the way so they're not in the way anymore. I'm going to set this in the center. I use, and this looks like a mess, but this is flux. This is an agent that makes solder flow better. I'm going to take a little bit of it. I've been using this same pot for a while. Don't use rosin core. You can buy, don't use flux or rosin core solder. It just isn't worth it. I'm going to put a little dab in each of the legs. Resistor legs are super easy to solder, so I'm not worried about them, but it's when we get on the chips that I want to make sure that it's even more so. I'm using a lead-free solder. This board does actually have lead on it. You can absolutely mix lead and lead-free. It's not that big a deal. This is not a high-voltage analog device like an old RGB CRT monitor that tends to need leaded solder. I've got my fan going, so even if I do kick up any of the fumes off of the lead that's in these traces on the board, it's not going to bother me. I'm using a conical tip. You'll notice it's a little cloudy right now, so I'm going to do two things. I'm going to brush off here in my clean off thing, and it's a little bit better, but I'm going to go over here into the tip tinner. And what a tip tinner does is it puts little beads of solder on it, and now it's nice and bright. You can see the tip on that is bright, and it's going to heat the solder up better. I come in from the top since I'm right-handed. We're going to do this first leg here. Heat up the leg, and you'll notice after you heat it up for a little bit, it'll actually suck down into the hole of the through hole on the PCB. So we're going to do this one here. There we go, that one's in there. Let's do the top resistor. Let it sit there for a second. I typically I have my Weller soldering iron set for 650 degrees Fahrenheit. You can do your own translation to whatever that is in Celsius if that's how you manage your measurements on your soldering iron, but it seems like it's around 260, I think is what the Celsius translation is. I don't have another scale beneath mine because mine's an American model, so it is in Fahrenheit. And we've pretty much completed the first part of these. I'm going to clean the tip off a little bit. It should be fine until the next time I use it. Now I'm going to use some of these flush cut trimmers here, and I'm going to very carefully hold onto the wire so they don't go flying. I used to save these because they are good for bridging things, but I have so many of them that I don't need to keep them anymore. I'm going to cut them with about a 1/16 of an inch gap between, maybe a little bit less, between the top of where I'm cutting and the board. So I have these 6 legs to get rid of. And then one last thing that I like to do is I like to come back in and reflow that solder, just to make sure now that the leg's not in the way, so I can get a good bond with the copper that's inside the via, the passageway between the bottom of the board and the top. And I'm just remelting the solder a little bit, letting it flow in. And you'll notice if there's any residual flux around it, it'll also kind of come into place. Okay, so that is the 3 resistors. We're going to take our Quake putty off, our rubber eraser. If it sticks a little bit, because sometimes it gets hot, you can actually use the eraser as it cools down to pick up the spares. So we have those 3. Now we have the 8 balance capacitors. These are 100 microfarad capacitors. And the way you can tell that, it's very difficult to see, I'm sure you can't see it on the camera, but the code that's used on this capacitor is 104, which stands for 100 microfarads. In old days, you would have seen these as larger lentil-shaped, kind of tannish colored ones. These are the same, it's just our technology has gotten much better. The board is set to this size. These are very robust little devices. These are actually rated for much higher voltages than you'll ever see on this board. So we have a couple of them. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. I like to do it so that I can actually see the code. Again, you'll need some spectacles, but I can see the marking there. It's 104. We're going to put one up here, and I'm going to place them first, and then I'll put the quake hold on them. And then we're going to put one other side here. This is the one that's used for the sound chip. I think I actually have 9 of the capacitors here, just in case I lose one. They are small devices. They're fairly inexpensive. You can get them for less than, 1 or 2 pennies a piece if you buy them in bulk. What these capacitors do is these maintain a constant, clean 5 volts, very close to the power input on all of these devices. In most TTL chips that run 5 volts, the upper right-hand corner is the 5-volt supply for most of these devices. So if you have a capacitor like this, very close to that leg of the chip, it's going to keep a constant clean 5 volts running, and 100 microfarads responds quickly enough to make sure that as this device is doling out power along its various legs to send different signals, that it is going to do that. So we have that. We're going to put these little blobs of quake hold putty on these to hold them in place while we flip it over and solder those in place. Now they're going to stand up fairly vertically. If you want to later, they don't take up much height. They're not much taller than about 3/16 of an inch at the most. So I'm going to put these in, and then if you want to, you can fold them back. I'll give you an example like the one here. If you want to fold it back, you can, but these are not the tallest items. Back in the days when they were the circular, again, lentil-shaped ones, a lot of the time you want to fold those capacitors, it's called folding the caps, back so they didn't stand as proud. So we're going to flip this over. Again, we've got 1, 2, 3, 4, 5, 6, 7, 8 of them. We've got the RAM chip and the ROM. We're going to put a little bit of flux on each of these legs. It's just about the perfect width between the 2 legs for the Q-tip head that I use here. This disgusting Q-tip that I've been using for, again, about 2.5 years. I generally clean this out. Even though it looks terrible, it's perfectly fine. Flux, if it gets junk in it, it'll just bubble up to the top when you're done. This is the angle that I like to work from for these because I can get a good angle. You can see that corroded up a little bit, but since we've already tinned it, all you have to do in this case is just kind of wipe it off. So we're going to do each of these 16 legs. That's 1, 2, 3, and remember, I'm going to come back in after this and reflow them once the legs have been cut off. These are not difficult to solder, so I'm not particularly worried about them. They tend to stick pretty well. The ground leg, which in this case on this circuit board for these are non-polarized. You can put them in any order. It's just on the circuit board, the top legs, the legs to the picture of the screen, is the ground. The 5 volt is closest to the 5 volt leg here, so that's why the top legs are just a little bit harder, because the whole back of this circuit board is a ground plane to help reduce noise. And you notice I didn't even need to put any solder on the tip because I'm kind of carrying a little blob with me moving through that. We've got 2 more of these left, 1, 2, 3, 4, 5, 6, 7, 8 up here. And again, we are going to hit these again with the soldering iron after we take the legs off. Notice the fan pulls the fumes off very nicely, so I almost never have to worry about breathing in these fumes. Got a little bit left. We're going to go ahead and clean it off like that, set the solder aside. Once again, we're going to trim the legs off. Again, leaving about 1/16 of an inch or less. I don't cut it flush to the surface. That can be problematic later on. It's okay if they stick up, again, 32nd to a 1/16 of an inch. It's not a big deal. So we've got 4 of them done, 5 done, 6, 7, and again, I'm just pitching these little legs off to the side. This is a spare. Again, occasionally my hands will go crazy and I'll fling one across the way. All right, so now I'm going to come back in and again reflow this. And what you'll tend to notice is it will get hot and then the solder will kind of suck down like a straw into the channel, the via between the top and the bottom. And it's lined with copper so that there is a connection between the top of the hole and the bottom of the hole. And each of these holes have a little rim of exposed metal around them. And in fact, I'm starting to collect a little bit of extra solder here. And there it goes there. Take this extra piece off. A little bit more than is needed. Again, we notice that the top leg tends to be a little more sluggish in terms of reflowing because it's attached to a large piece of metal that pulls the heat away from it. This one's going to take a little longer. There we go. Down. And again, I know right now they look kind of charred around the edges. We will absolutely take that off. You can use a combination of alcohol, isopropyl alcohol. I actually use a degreaser crud cutter, which is a type of spray-on cleanser that I use that I think works much better. We take all of our pieces off. They look nice. I'm going to take all of our putty off, I meant. Not too bad. We're cruising along here. Let me check the video, make sure it's still recording. Yeah, we're at about 12 minutes. That's not too bad. Making good time on this. And yeah, I've been doing these for a while, so I'm going to be much more efficient at, soldering this stuff than you are. But again, this is not a difficult skill to pick up. Okay, the next tallest component is probably going to be, we're going to put these header pins in here. These header pins allow us to select which bank of 16K that the ROM is going to use. Now, it doesn't really matter. It doesn't matter which one you select because in the image that I have created for these devices, this one's a little challenging. So what I'm going to do is I'm going to set these above that. I'm going to put a piece of the putty beneath it, and then I'm going to kind of mash these into it to keep it at a height. And you'll notice that I've already put the jumpers on them. What that does is that helps me keep it at a height that is manageable, so you can still add or subtract the jumpers or move them around. Again, by default, you don't really have to worry about this setting because the same thing, the same image for the ROM is recorded in all 4 banks, so it's not going to be a big deal. I'm going to kind of pucker this up. I'd like to make sure they're a little bit straighter. Push the header down, and I think that's good. I'm going to turn this over, and notice I'm going to put it at an angle, and I'm going to press down. I'm going to rub a little bit of flux right next to those pads, so they've got something to help them flow. I'm going to press down on the surface a little bit to make sure those pins are sticking all the way through. And then I'm going to come in, and these pads are more oval shaped. So you want to get solder on both sides of the pin, on both the top and the bottom. There's that. And we've got 2 more. Okay. that's good. And I'm going to reflow these again just to make sure that that kind of sucks down into the via a little bit. So you hold it here, 1, 2, and then right there is about when it sucks down into that passageway. These do not need to be trimmed off because they are already fairly low. There is a set of jumpers that I already trimmed off. These actually had much longer legs. These are from a different project that I had. When you buy it, yours will probably be stacked as a single, 2x8 header, which is perfectly fine. Mine does not. So I'm going to take this putty off, make sure that the header pins are there, and that looks good. All right, next thing in terms of height, we're going to put some chips on. So the 4 chips that we're going to put on are the RAM chip, the 2 address buffers, and the clock divider. So we're going to start with the smallest one here. The way you set chips, the way you look for them is there is a little indentation. If you're looking at the Aquarius so that you can actually read it right side up, if you can read the chip, it should be a 74LS 74, and there may be a couple of letters before, a couple of letters after. Make sure the legs are straight, and you're going to make sure this little notch at the top lines up with the notch that's on the silk screen. So it's going to go right here in the middle. Now this particular chip is a little loose, so I'm going to put a piece of the putty over it to hold it in place. And just to save some time, I'm going to go ahead and put all 3 of these chips in place. We've got our address buffer here. Looks like that one's a little cruddy. I think these were harvested from a board, so there may be a little bit of solder on these. And that should make it a little bit better. But again, we're going to put these on here. Again, make sure the notch is to the left so that it matches the silk screen. This is the upper address buffer. I'm actually having problems putting that in, so I'm going to try and reflow this in while it's there. Is that sitting right? Yeah, looks like it wants to still look a little proud of that. So I'm going to try and melt this. There we go. So it's now in place. That solder will probably hold it in place, but I'm going to go ahead and put a piece of putty on it. And then this one also came from, it looks like it has, its legs are a little bit cleaner. These are exactly the same 2 chips. These are both address buffers. It doesn't matter which one you put into which socket because they both do the same thing. One does the upper set of the address, the upper 8 bits. The other one does the lower 8 bits. Figuratively, they're actually kind of mixed up a little bit, but for simplicity, that's what we're going to say. Okay, so we're going to flip this over. Again, I'm going to go at a slight angle here. I'm going to push down on the putty. We're going to get some flux in here along the pins to make it flow better. Do this here. That should be plenty. Again, we can always clean this off later. Not a big deal. Push a little bit harder on this pin. So, depending on the height of the putty, I'm going to do a trick where, to make sure that the chip is in as far as it needs to, I'm going to push down while I solder a couple of the legs in place. So I'm pushing down on the motherboard here, on the PCB, and I'm going to take this solder, get a little bit of it, put it right next to the leg, and I'm going to use that solder to anchor that corner in place. Now I'm going to do the same thing down here, so they are diagonal from one another. I'm going to push down so that this chip is as tight to the PCB as necessary. And if I wanted to, I could now take the chip hold off the front of it, but I'm not going to. I'm going to do the same thing over here. I'm going to push down on it, on this PCB, and solder it while it's in place. So we're going to push down, let it flow into that pin, into that leg. Okay, so we've got some here. We're going to hold it in place and let this leg flow. Okay, last one is the the address buffer, the push down on it, solder this upper leg into place, push down, solder the lower opposite corner leg into place. Now, all of these chips should now be as tight against the board as possible. In fact, I can, if I want to, I can take this quake hold on. They're not going to fall out anymore because I have them soldered in at each corner, so it's going to hold it. And again, if you look, they are very close. They're as close as you can get to the surface of the PCB. So I'm going to take the quake hold out of the way. I'm going to put this chip here. We still have flux on it. And I'm just going to go down each of the pins. 1, 2, 3. Lots of pins on these address buffers. There are 10 pins on each side, so these are 20-pin chips. Or maybe are they 18-pin chips? I can't remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, they're 20-pin chips. And I got a clarification from Mac Wharton, one of my friends in the Aquarius, when I was talking about these address buffers and some of the problems that they cause. What it does is it's not so much that you can't send data back and forth through the address buffers. It just makes it impractical to do what's known as DMA, or direct memory access. So thanks to Mac for giving me some more correct information on what these address buffers do. But they do stabilize the MX, so that's why I use them on this particular device. All right, let's see here. Rattling along pretty quickly, and again, I am going to go back through to reflow these just to make sure that they are as well seated as they can be. Starting to lose a little bit of, so it looks like it's good. I've got a little bit of darkness on one side. I'm going to retin this tip, let it melt in place, and then rather than wiping it off, I'm going to continue straight on into soldering onto this board. Now that I've got a nice smooth coat of solder on the tip, the heat is flowing really well. If you tend to use a soldering iron like this, you want to vary where you hold it, because if you continue to solder in one particular position, particularly if you don't clean the tip on your soldering iron, your tips will wear out. And the way you'll notice that they'll wear out is they'll start to get a little cup on one side, because the solder itself is actually kind of corrosive to the steel in the end. Not the solder specifically, but components in the solder. All right, so we've got the two address buffers kind of tacked down. We're going to go ahead and put the clock divider in. This one has far fewer legs, so it's a little bit faster to work. What this clock divider does is it takes the core clock from the Aquarius. It's called the PHI, so it's a Greek symbol. And it divides that into a clock frequency that the sound chip can run at. I don't have the exact frequencies, but it also depends the frequency at which your Aquarius runs at, whether it's a PAL-based system or whether it is an NTSC or CCAM system. I don't know if there are CCAM systems or not, but I know there are both NTSC and PAL systems out there. Okay. So these onboard chips, these just onboard base logic chips are there. I'm just reflowing these pins really well. Have a little bit of excess solder I'm going to scrape off of these. Move this set of flush cutters out of the way. Okay, a little more on that one than I wanted. Let's hold it for about 3 seconds, count to 3,000 and you'll get it. And it will just suck that solder down and around and give you a really good solid hold within that. Again, we are not going to trim the legs off of the back of this for 2 reasons. The inside of the Aquarius MX case does not have a heat shield, so there's nothing for this to short out against even if it wanted to. Second, even if there was, it would have more than a 2/16 or an 1/8 of an inch gap between the bottom of the boards. And there are other components on the back of this, like the mounting holes for some of these that stick down far further than that anyway. So again, we're just reflowing these pins on the address buffers. Just takes a little time, but make sure that everything's in place much better. You can tell when solder is flowing well because it's nice and silvery, even if it's non-leaded solder. Generally, you can tell the difference between leaded solder and non-leaded solder once it's cooled down. Unleaded solder tends to be very matte, silver colored, whereas leaded solder tends to be shinier in its cool state than leaded solder does. So we've got a few of these legs left. The next thing we're going to solder on is the RAM chip. And remember, I said that the reason you want to solder the RAM chip in is there is absolutely no benefit to socketing it. If for some reason you bang around the MX and you have the RAM chip in a socket, it can come loose and that can actually damage it. So since this has so many legs, I'm going to pre-flux the back of this because I want it as close as possible. And when the legs are sticking through, particularly with the chip this large and definitely with the sound chip, the socket for the sound chip anyway, we want to make sure that we have that. So here is the RAM chip. We're going to slide it through. Okay, so RAM chips generally have a little bit of an angle on the legs. What I do is very carefully tilt those legs in so there's a little bit of a bow to them. You can kind of see now it's a little bit different. They're angled in a little bit. Again, make sure the notch is lined up with the notch on the silk screen. This is the CY 62256 LLPC. This is a through-hole version, and I'm going to make sure that this sits in place. The bigger the chips, sometimes the harder it is to get the legs to line up. Make sure they're lined up before you press really hard. Since these chips bow out a little bit, I don't really need to put the quake hold on it because they've got a good through-hole stiction to it. Just in case I get crazy and my hand shakes and I throw this off the thing, I'm still going to tack the corners, but I can see that these are so well mounted in the thing, I don't need to push on the top of the chip. Okay, again, I like to work at an angle, so I'm going to come in here. You can see my tip here is a little bit clouded up. I'm going to see if scrubbing it works, and it seems to. That's good enough. And these are, I can't remember how many pins. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 pins. That's right. 28 pins. Most logic chips that access, memory chips or RAM chips or ROM chips have to have at least 16 pins, 8 for the data bus, and, at least 24 pins. 8 for the data bus and 16 for the address bus. Plus then they're going to have like a chip select pin which turns it on or off. They will also have some higher bank addresses available. They'll have, for this one, there is a chip that you can activate at a slightly higher voltage, at a higher voltage of like 12 volts, and that's how you program this chip, because this is a RAM chip, so it doesn't have that. But there are other chips. But anytime you have a chip that serves as a memory or a data storage or source, it's going to have at least 24 chips most of the time. And of course, every chip has a power in, which on these chips is 5 volts, and then a ground, which is 0 volts, which goes to the kind of the universal ground. All right, we're almost done soldering in the RAM. And as with the others, I'm going to reflow these after I get the spool of solder out of my hand. I'm going to do a real quick reflow here. Again, these pads are oval, so they hold solder very, very well, both on the front and the back of the pin. So there's plenty of surface area. I just like to have the solder wick down into the via, the hole through which the leg goes a bit more. So we're almost a third done with this. I imagine we're probably at the 20-minute mark. As soon as I finish with this, I'm going to stand up and check to see what the progress of the recorder is. Like most people these days, I record this on my phone. It's much easier. The camera's better than anything I could possibly own. Yeah, it looks like we're doing good. Oh, wow, we're actually at the 35-minute mark. This is taking a little longer than I thought. I'm probably yakking too much. Okay, so what's next? Well, the next thing we want to do is we want to do the sockets for these. So for the AY chip, and I do recommend that you socket the AY chip. The reason for that is sometimes these can just spontaneously go bad, and it's not that it's impossible to desolder this, but again, this thing looks like 40 legs on it. That's a lot of legs to desolder. So for preservation, and since we have plenty of height in here, I recommend putting the AY sound chip into a socket. Again, that is a dual inline 40, I believe. This one will slide out, so I'm going to use 2 pieces of the Quake hold to hold it in place. I'm going to do it actually over the front and the back. And notice when I put this, I'm going to double these up. Notice that there is also a notch here. I'm going to put that in line with the notch on the silk screen so that when people use when people insert the AY sound chip, they will remember where it's supposed to go. This should hold it in. I'm going to keep it as nice and tight as possible. I'm also going to solder in the ROM chip. And again, we might need to, at some point in the future, update this ROM. That's why I recommend that it is in a socket, because if you have it soldered in, it is really difficult to reprogram if for some reason, and I'm sure we will, we ever want to update the software that's running on that. Similarly, we're going to do these pair of sockets. I didn't have sockets that are this size. These are same size as the address buffers, so I use a 9 and a 3 together in both of these, because I don't have a 20-pin socket for those. So we're going to do the AY and the ROM sockets really quickly. I'm going to move this out of the way. I forgot to put the flux in there, but this should be fine. Kind of looks like a Halloween ghost with its little snoot on top. And we're going to put this here. Get plenty of flux to flow. Flux is a resin. It's actually more of a rosin that works in conjunction with the metal in the solder to promote flow. But it can be corrosive, so you do need to clean it off after you're done using it. There are some versions of no clean solder. I have not found them to be as effective at flowing, and I still find them, and maybe it's just because I'm anal, but I find that they need to still be cleaned after they're done, so I don't pay more money for that. I just use good old standard solder flux for that, paste flux. You can kind of see up here, I do have a thinner type of flux that I use for surface mount chips. I'm doing some other work on another Aquarius project that does have some surface mount items on it, but that's more for making sure the surface mount solder, which is a different type of solder, it's a paste solder, make sure it flows better, and sometimes I'll need to reposition the chips, so that's why I have that flux there. But it's much more expensive, it's much thinner, and I don't need to waste it on these devices. Okay, so we're half done with the ROM socket. Coming to the end of the ROM socket here. Again, lots of pins on this thing. We saved the biggest one for the end. And this is a 40 pin socket, so there are 40 pads to solder total, 20 on each side. I'm going to reflow or retin it a little bit. There you go, nice and clean. Wow, it's like night and day difference. Solder just melts right onto that tip when it's been tinned. The tinning compound is just powdered solder. There's no flux in it or anything like that. There's a little bit of rosin mixed into it. And half done here almost. Yep, half done on the AY socket. Let me go on the back side, back 20 pins. Clean that off now, 'cause it's got a little bit of dross on it. And I try not to keep the soldering iron on these pins too long to begin with, because again, they're embedded in plastic, and if I keep the soldering iron on it too long, I can warp the plastic, and I want to make sure that the plastic stays in shape so that the chip, the AY sound chip, has good connectivity to the socket. 2 more of these. We'll do a quick reflow on both of them. So this is the ROM. Looks good. There we go. Just looked up to make sure that my soldering iron was still at temperature. Sometimes if you do too much soldering at one time, it can actually bring the heat down to a point where the soldering iron actually isn't being effective at all. But it was okay. Okay, done with the ROM chip reflow. Let's kind of shuttle through the AY socket. And again, if you are not as experienced in this, you don't necessarily have a very small type of soldering tip, make sure that these aren't bridged. That's a kind of a common thing. If you have a larger soldering iron, that these can be bridged. You want to make sure that's not the case. You don't want to create any shorts. And that will be one of the last steps. I will go through and look at all of these solder joints to make sure that I haven't missed any. I've soldered many boards in the past where I've come back and I've completely missed a leg. Either I looked somewhere else to add solder or clean the tip and kind of forgot where it's at. So I always make a secondary look. It's a good idea. This one has so few pieces that it's kind of unimportant. I'm going to go ahead and pre-solder the areas where the gal chips are going to be. Again, we're going to use 2 sockets on these, a couple of sockets. We're going to take this off of here, that off of there. So we are going to use a combination of sockets. So here is the board. We're going to put the 9-leg chip in up at the top, and again we're going to keep the notches, and then we're going to put the little 3-leg, and there are some 6-leg chips like this, the little 6-leg chip at the bottom. Going to bridge, so we're going to do this, break this back into 2 pieces, and I'm going to put 1 piece at the back here and 1 piece on the other side of the back to kind of hold these both in. And again, I'm going to mash this down. Similarly, on the other side, for the other, I'm going to make sure the notch lines up at the top, set it in carefully, make sure this little notch is also going the other direction so it doesn't confuse the users. So it's all going that way. I'm going to take this piece, pull it into 2, put it on one side of the chip sockets, this one on the other side of the chip sockets, make sure that it's good. These down here. I'm going to mash this down. I'm going to lift it up and then mash it down so that they're pushing up as far as we can. Soldering tip looks pretty good. I don't need to retin it. So we're going to do, remember this has 2 different sockets in it. So we're going to do here and here, and then here and here. Similarly down here we're going to do upper and lower and upper and lower. So I can now, if I need to, take the quake hold off the front, but I'm not. It takes too much time. We're just going to go down the legs here. Again, these are the gal sockets. Normally they are 20 pin sockets. I didn't have it, so I used a 9 and a 6, sorry, an 18 and a 6. Is that right? 2, 4, 6, 8, 10, 12, 14. 14 and a 6, so it's a total of 20. Either way, the bill of materials is right. You can order like the legit 20 pin sockets for these. Okay, so that one's done. Let's go ahead and tack down this other one, and then we'll reflow them. All right. I'll try and use the back side of this soldering iron now so I don't wear out the front. There we go. Once there's solder on it, it tends to behave well, but sometimes if there's a little bit of crud on it, it's a little more challenging. That's a good example, so I'm going to retin it. And we'll reflow this. Okay, I think let's go and tap these really quickly, let them straw down into the via. I think this is the last socket, chip socket we have to do. Next we're going to put in the reset IC, which looks like a transistor, but it's not. So let's take this quake hold off. And again, these are both about the same size. You'll notice that they look very similar. This is actually the transistor, and if you look up close, you can see that it is a BC 548. The flat side that you see here lines up with the flat side on the silkscreen markings. Gotta splay the legs out a little bit so that they fit better. A little tedious, but let's see if we can make that fit a little better. And again, just make sure that it matches the BCE configuration of this transistor. You want to make sure that it's the base, or sorry, CBE, collector base emitter format, and you can see those silk screened on the PCB itself. So this is going to hold that in place. This, although it looks like a transistor, is not. This is actually a special type of a circuit that checks to see if you have a full 5 volts. If there is anything less than 5 volts, it will hold the reset line on the system in place so that it won't start up until it's got a full 5 volts. Also, flat line, there is no CBE marking on this. Just make sure you're using the proper DS1233. It's called an Econo reset. When you put it in place, it should kind of snap in. Whoops, there we go. And then since it snaps in, the legs are already kind of angled. You don't really need to use quake hold on that. These are at an angle, so I'm going to try and get one that handles both. Put a little flux on them so they flow better. Let's put these guys in. Here's the Econo reset. Oops. And there's one. There's 2. And here's number 3. Looks great. I'll do it on the actual transistor down here, the audio transistor, part of the amp circuit. I'm going to move this a little bit. Now, this is problematic. Is it not? Oh, I wasn't actually touching the pad because the leg was in the way. So we're going to reflow these, make sure we get lots of connection through the via. And on this one, I tend to drag these up. This one's there. That one kind of stuck through too. And there's that. Okay. We're going to take the legs off of these guys. And particularly with the Econo reset, this guy here, you want to make sure that these legs are not touching. The pads on this footprint are a little different than the ones on the transistor here. So they're a little bit closer, so I just want to make sure that these are not connected. And you know, they look like they are, but they are not. So this blue area, the PCBs look really pretty, but they have this blue photo resin on it that actually doesn't attract the solder. So there's actually little lines of that between. That's why the pads generally don't stick together. Okay, we're getting closer, almost there. Almost everything is done. Now we're going to do the this electrolytic capacitor. Notice there's a little pinch at the top. It matches the pinch that's there. The positive side is closer up. That is the pinched side. The negative, there is a line on it which points to the back, goes closer to the edge connector. So we're going to bend this very sharply in place. Set it down, put a piece of quake hold on it to let it get in place. Flip it over. flux on it. Flow this solder in. There we go. And on this side as well. This balances the power, the master set of 5 volts, the master, what they call VCC, voltage common, across the, from the Aquarius. Aquarius is where the MX gets its power from. And then just because this chip is, or this capacitor is so important, I'm going to go ahead and put a little bit of solder on this side because I can, because I've got access to it. And then over here, looks like a little of the solder bled through anyway. So I'm going to put it right here. And that looks great. Okay, now let's do the ports. This is the AY expansion port, and I did not, gosh, I didn't grab the right pins for that, did I? Thought I had the right ones. It's too big. Well, we'll take care of that in a second. In the meantime, let's do the pins for the CH module. We are going to be facing the USB port out, so we put it on this side. If you wanted to, for any reason, put it inside, you put it on that the other end. But we're going to be facing it outside of the back of the case. I'm going to take a couple pieces of quake hold these pins in place both together and as vertical as possible. So we're going to try and make sure this lines up. Probably should have put the flux in before I put them through, but it's also kind of messy to do, so we're going to take that off. Let's solder this in place. I'm going to go along the top, and then I'm going to flip the board around. Probably coming up on an hour on this build. Sorry it's taken so long, but should give you a good sense about how much time you should plan for yourself to build this once you have all the components. This is also a good indication of, you know, if you're buying this from somebody, realize this is taking them, you know, the better part of an hour just to assemble the PCB. So, yeah, I wish I could get this for 78 bucks. Well, the parts alone are about $100. If a person is only charging you, you know, $100 for this, they're not making any money at all unless they've, you know, already got the parts or were able to get them cheaper someplace else. They're not making much on this, so be nice to the people who are making these for you. Just because you want it for free doesn't mean that you're going to get it for free. The other alternative is, yeah, you can do this. You can do exactly what we're doing and make these yourself. We're going to reflow these. And then I'm going to go and try and find the proper header for that sound chip I/O. So there's that. Let's pull this off of there. Looks nice and clean. Let me see if I can find that header. I thought I had them up here, but it is a different, it's a 20-pin header. No, it's exactly the right one. I was wondering what was going on. It just looks bigger because of the way it sits. So that is exactly the right one. I did grab it. I didn't think I bought larger sizes. So it's in place. It's nice and flush. We'll put a little bit of solder flux, sorry, a little bit of flux over here. So it's in place. Crank through this soldering really quickly. We are very close to being done. You want to make sure that the key, you'll notice there's a little notch on one side of this. The standard interface cable, I made a a diagram for it. It's on the, I'll put it in the GitHub, but it's more about joysticks than it is necessarily about this particular interface. The interface cable that I have that is an alternate to using these ports relies on the key being down. If you want the A controller to be on the side that is normally the A controller. I'll show you when I flip this over here in just a second. Just know that this is a keyed header that takes a keyed cable that assumes that the A values are going to be on one side of the header. Again, just free flowing these real quickly to kind of take the size of the solder blob down and fill into that hole a little bit better. Provide a better mounting surface, less chance that it'll get a solder joint crack. There we go. Hopefully the battery on my phone is holding out. It'd be really disappointing if I stand up and it's already gone. But I don't think it is. I had it fully charged when I started, so. Okay, so this header is done. I think all of the headers are completed. The last thing we have to do in terms of soldering is put the ports on. As I mentioned in the last, or in one of the earlier videos, these are automotive grade ports. That's why they're expensive. Notice they don't have screw mount holes. They have nice mounting ports on them. What you do is you slide them very carefully into the solder holes and you pop them into place. These little plastic tabs hold them in. Since the plastic tabs hold them in, you don't really need to do more than that. Just you don't need to put the quake hold on them. There we go, snapped in place. And we're going to solder these. Let's put a little bit of flux on them. All right, let's get these soldered up. These only have 9 pins each, so that goes pretty quickly. And if you're wondering which pin on the motherboard goes to which pin in the DB9 kind of, you know, chevron, not chevron shape, but the kind of a little polygon shape, they match one for one. So this is the one that's up here, this is the one that's up here. You can trace them back very, very easily. To that end, if you didn't want to buy these ports, and again, these ports are not cheap. I managed to find them for about 11 bucks a piece, US dollars, but the original versions that I found were like $16, so they are not cheap. There are metal versions of that, but their tabs and their mounting holes are in slightly different positions. You would have to cut them off, and also they have hard-mounted screw posts that will poke into the case as it's designed, so you would either need to drill out the case or melt them out. Or somebody could, you know, if somebody was motivated, they could, this is an open source project. If you wanted to rebuild a different PCB that took the cheaper parts, you could absolutely do that. And it may be more cost effective for, you know, for builders to say, hey, you know, these through-hole parts, they're actually a little more expensive to find than more modern surface mount parts. I would rather do that. Since I'm going to be assembling it for most people anyway, I'm just going to go ahead and use surface mount parts myself because they're cheaper, they're smaller. So you may find some people who rework this design, and that's what I want. I want people to use this design. So this is the soldered up Aquarius MX. The GI sound chip goes up here. Again, you lock in that position there. Again, the legs on this are a little bit splayed apart, so I'm going to bend them in just a bit so they don't go bending outwards. Line them up like that, push in a little bit, make sure that none of them have gone in sideways so that the legs don't get all bunched up. This is the hardest one to deal with, so it looks like it's in place. We're going to take the ROM, again it's also splayed out a little bit more than I like, so I'm going to bend those in. Again, make sure the notch is over here, set it into the socket, and you're good to go. On low for both of these headers, similar on the AY, the legs are a little bit splayed. It's harder on these because they are shorter. Just kind of very carefully roll them in place. The AY goes closer to the AY. So the AY goes up here, and it also says so on the silk screen. That's that, to make sure it's nice and locked in place. The MX RRU, RAM, ROM, and USB. We're going to fold these legs in just a little bit. If you have a commercial, chip leg straightener, that'll work too. And again, it goes closer to the ROM and that. Set that in its port. Lock it down and in place. That is the completed set of circuits. The last piece is to take your CH376, and just to make sure, remember you're going to put it in like this. First thing to check is to make sure this back row, that the signals are correct on this. Don't touch this. It should look like in the upper left hand corner of the power supply up there. That's fine. Make sure going from the bottom to the top are all the data signals. Data 0, 1, 2, 3, 4, 5, 6, 7. They should go exactly the opposite way on the back row of this. 0, 1, 2, 3, 4, 5, 6, 7, because when you flip it over, 7 will come over to here. Also do a quick check down the row to make sure that the right signal is down here, the read signal is next to it, then chip select, an A0 marker, interface pin, and that it ends up with 2 grounds on these pins. So that all matches for me. Before we plug it in though, we are actually going to we're going to build up this device. So the way we're going to do this is we're going to take 2 screws, and these are nylon screws. I've already spec'd them out in the bill of materials. You're going to feed them on, I forgot, we're going to feed them on with one of these microscopic little M2.5 washers. Put that there, because this is going to raise the USB port up to exactly the right location. So we're going to lock that in place. We're going to put the other screw at the bottom. We're going to put the second washer on it, put the post on, lock it in place. We're going to take the last 2 washers, set them on top, and now we are ready to mount the CH376. Again, line it up to the back so that all those pins line up, and carefully set it in place, and the legs should line up perfectly. Press carefully in place, and you'll notice that it angles up just a little bit. That's okay. And then the last thing we're going to do is we're going to take these M2.5 nuts, twist them down in place, and this is what keeps our USB port in place solidly, after you constantly plug in and plug out the USB drive, or the variety of USB drives. I finger tighten them first to make sure that it's all locked in place, and then I'm going to take this set of pliers and just kind of lock it down a little bit. If you want to use, a thread lock on it, you can, but you generally don't need to. So that's it. That is the Aquarius MX built from the ground up. What I'll do is I'll take this in the other room, I'll spray some of my spray on, or use a toothbrush, clean all that up so it's going to look pretty. And our next step is going to be taking this cleaned up board and actually mounting it inside the 3D printed case. So I hope you enjoyed that. Feedback as usual.